Today, my talk is validation for NLDAS and GFS soil moisture and application to National Soil Moisture Network and US Drought Monitor. First, I want to acknowledge my co-authors Helen Wei, Mike Balaj, and Daryl Klist. This slide gives you an outline. The outline includes introduction for NLDAS, Geodata, and GFS, station observations and satellite retrievals, validation for model soil moisture, application model soil moisture product to US Drought Monitor and the National Soil Moisture Network, and finally give you a summary. This slide shows the NSAP EMC NLDAS website. NLDAS run 4 land surface models: NOVA land surface model, Mosaic land surface model, Sacramento model, and the Wake model. All 4 models produce soil moisture for different soil layers. The details please see EMC NLDAS Drought Monitor and the NASA NLDAS website. This slide introduces the NSAP GFS V16 Geodata system. The Geodatas run NOVA land surface model in weakly coupled mode. Geodatas use updated land dataset for the vegetation type and soil type. Use the GDAS atmospheric forcing and gauge-based CPC daily product. The Geodatas using GDAS initial for daily run. The spatial resolution is 13 km and for global domain. The Geodatas provide operational GFS land initial conditions, including liquid and frozen soil moisture as well as soil temperature. This slide gives you a summary of model product. NLDAS include 4 land surface models and run the land model uncoupled for NLDAS domain, include corners, South Canada, and North Mexico. In 1H degree resolution, the period cover from 1979 to present. The GFS V15 run NOVA model in coupled mode. Global domain 13 km resolution. The data period cover from the June 2015 to March 2021. And the Geodatas GFS V16 run NOVA model for 3 days offline. Use the GDAS forcing and the CPC global daily gauge-based precipitation. Global domain 13 km resolution. The data period cover from June 2019 to present. This slide shows station observations and satellite retrievals. This shows national soil moisture work. And this is the International Soil Moisture Network. And this 2 part is include all the in situ measurement from the national and global stations. This is satellite data, include SMOPS and ESA-CCI. Besides blended soil moisture, they also include separate satellite retrievals, such as SMAPS, SMOS, ASCAT, and AMSR, and Central. This slide shows validation for GFS with observations. Top panel shows 10 cm soil moisture validation, and the bottom shows 10 to 40 cm soil moisture validation. The red line is the observations. Blue line is the GFS V15. Green line is the Geoda's GFS V16. If compare the time series for the different stations and models, the result shows the GFS model can generally capture the observed daily variability, but not magnitude. GFS V16 has a lower soil moisture than the GFS V15. The two GFS results are much more similar to each other than to the ops. The QA/QC is needed for real-time station measurement for some station prairie. This slide shows validation against NLDAS, SMOPS, and ESCCI for Grant Plain. The top panel shows NLDAS validation. The black line is GFS V15. Blue line is GFS V16. And the green line is mosaic. Red line is NOVA, and the orange line is weak. The results shows GFS soil moisture is comparable with NLDAS, although NLDAS weak is better. The right panel shows the SMOPS, include SMAP, SMOS, near real-time SMAP, and near real-time SMOPS. The result shows SMOPS, SMAP, and SMOS is helpful for model validation, but near real-time SMAP and SMOS is limited for validation purpose due to a lack of QA/QC procedure and many missing values. And the bottom left shows the validation against the ESACCI. The ESCCI combined is green. Orange is ESCCI passive. Red is NLDAS NOVA. Blue is Geoda's GFS V16. Black is GFS V15. The result shows the ESCCI is useful for GFS soil moisture validation. This slide shows validation against the satellite retrievals, include ESACCI combined, ESCCI passive, SMOPS for North America, Africa, Asia, South America, Australia, and Europe. The results show GFS soil moisture is drier than satellite retrievals, and GFS V16 is driest. A passive is wettest when compared with others. This slide shows application model soil moisture product. This is an application for US drought monitor. This slide shows application for the monthly CPC drought briefing. This slide shows the NLDAS application for National Soil Moisture Network. This slide shows a summary. GFS soil moisture is compared with NLDAS station measurement and satellite retrievals for the 2019 summer. The result shows Geoda's GFS V16 is drier than the GFS V15, and the satellite retrievals for nearly all regions. Both station measurement and satellite retrieval help for validation model soil moisture. The result shows the model can capture the observed soil moisture daily variability when compared with station observations. However, model cannot capture magnitude well. The NLDAS has been applied in National Soil Moisture Network and Operation US Drought Monitor. Hopefully, Geodata model-based soil moisture will be used in the International Soil Moisture Network in the future. That's all. Thank you for your attention. If you have any comments and suggestions, please send an email to Daryl. For technical support issues, please send an email to me. Now, I'd like to take your question. Thank you.